Hello and welcome to T2 Day 15 of Honors Precalculus. Today we're going to talk about the law of sines and cosines, two very important laws. But before we get there, we're going to warm up. So first, we're going to evaluate the 6 trigonometric values for this theta value right here. First thing we're going to do is find this length here, and let's call it h. And we can use the Pythagorean Theorem, which we call the Babylonian Theorem. H squared plus 24 squared is equal to 25 squared. So therefore h squared is 25 squared minus 24 squared. So that tells us that h is going to be equal to the square root of this. Now, you could do this out on your own. If you use your calculator, you will find out that this is kind of nice. It comes out to be a nice value, which is 7. So this value is 7 right there. And here's a trick I use in my head when I do these. I like to rotate it so that the theta value is right there. This is just what I do. You don't have to, but it's going to be 25. This will be 24 and 7. I've just rotated it. It doesn't change the values of the trig functions. So the first one we're going to do is sine of theta. And sine of theta is opposite over hypotenuse. So that's going to be 24 over 25. And then we're going to do cosine, which is adjacent over hypotenuse, k-a-h, 7 over 25. And then we're going to do tangent, which is just going to be 24 over 7. And then there are 3 other trig functions that we need to know, and each of the reciprocals of these. So this is going to be cosecant of theta is the reciprocal of sine, so that's 25 over 24. And then the reciprocal of cosine is going to be secant theta. It's going to be 25 over 7. And then you're going to have cotangent of theta is going to be 7 over 24. On the second question, it asks us to solve the triangle, and that means find the missing side lengths and angles. So we'll call this alpha, and we'll call that theta. Those are 2 angle values. And then we'll call this down here, let's just call it, I don't know, we'll call it b for base. So b squared plus 15 squared is equal to 39 squared. So b squared is equal to 39 squared minus 15 squared. And when you do this out on your calculator, which you can do also by hand if you so chose, you're going to end up with being 36. So this base is 36. So when you do this out, if we're going to find the angles, let's try to find theta here. Let's do theta. So theta, if we do sine of theta, that's just going to be 15 over 39. So theta is going to be sine inverse of 15 over 39. Now that's not a quote nice trig value. You will use a calculator to do that, and you end up with 22.620 degrees. 22. I'll clean that up a little bit. And then you don't have to do much more to get alpha, because you know that alpha plus theta plus 90 equals 180, because the internal angles of a triangle add together to get to be 180. So therefore alpha plus 22.260 plus 90 equals 180. So therefore alpha, when you do this out, is going to be equal to 67.380 degrees. So we have found alpha and we have found theta. We have now solved this triangle because we have the missing side length and the missing 2 angles. Now let's suppose we have a non-right triangle, so there's no right angle in here. Let's play around with it. And these represent angle measures right here, and these represent side lengths. So lowercase is side length and uppercase is going to be angle measures. What we're going to do first is we're going to drop this altitude, meaning we're going to create this side of an internal triangle and call that h right there. And then we're going to call, for the need of sine at this point. So if this is angle A right here, if this is angle A, what would be the sine of A? Remember, sine is so opposite over hypotenuse, So that opposite is going to be equal to h over b, because you have the opposite and then the hypotenuse right there. But then you also know that the sine of b, angle b right there, is going to be equal to h over a. Similar, the opposite and then the hypotenuse right there. So you can isolate h, and you get h is equal to b times sine of a, and here you get a times sine of b. But both of those are h. Both of these are h. These are bad highlighters, so I'll choose a different color for you. So both of these are h. If both of those are equal to h, what does that mean? It means that b sine of a is equal to a sine of b. So how do we rearrange that to make it into the law of sines? And keep in mind, we could have done this with any 2 of the angles, I'm going to rearrange this a little bit. I'm going to divide both sides by, let's say, a. So if I do that, you get b sine A is equal to sine of capital B, and it's over A right now. And then I'm going to divide by B. So it's going to be sine A over lowercase a is equal to sine B over lowercase b. And you can do the exact same work with any two angles. So this actually comes out to be a triple sine C over lowercase c. So this is the law of sines. This ratio is always the same. The ratio of the sine of an angle to its opposite side length. So keep in mind that side A is across from angle A. Same thing here. These are across from each other. These are across from each other. So if you set it up that way, this ratio right here is super, super helpful. So here's how we could use the law of sines. So here's our forest ranger at a ranger station A right here. Sights a fire station in the direction 32 degrees east of north. So if north is straight up, 32 degrees east of that is to the east, which is that. So the fire is right there. You like my fire there? Use some highlighters. A different forest ranger at a ranger station B, which is 10 miles due east of station A. So over here, here's station B. Call this station B, and it's 10 miles away. Sights the same fire at a line 48 degrees west of north. So what that means is it sees the same fire right here, and here's north again. But now we know that this angle right here is 48 degrees, and it's west of north, so it's going towards the west. Find the distance from each station to the fire. So how do we go about doing that? Well, what we first do is we fill in the missing angles here. So if this is 32, you know that the whole thing adds up to 90 for north right there. The whole thing adds up to 90. So this right here is going to be 58 degrees. And then over here, since this one is 48, this one's going to be 42 degrees. So what we can say is, let's say if this is A right here, we're going to call this lowercase a, make this consistent. And then this side length is going to be lowercase b right there. So what that tells us is that we could use the law of sines here, and we could say sine of 58 degrees over lowercase a is equal to, same thing over here, sine of 42 degrees over b. But we don't have either a or b, but we do have this side length. So let's get that in there, and we can find out what this angle is right here. This angle, we can just call that alpha if we want to. And we know that the internal angles of a triangle add up to 180. So 58 plus 42 plus alpha is equal to 180. So that means that alpha, when you do this out, is going to be 80 degrees. So this is 80 degrees. So you know that these two things are going to be equal to sine of 80 degrees over 10. So what you can do is then you can use this ratio right here to solve for each one. So here's the first one here. You know that sine of 58 degrees over A is equal to sine of 80 degrees over 10. And it also tells you that sine of 42 degrees over B is equal to the sine of 80 degrees over 10. You'll need your calculator because these aren't, quote, nice trig values. But when you cross multiply and you solve, you end up with A is equal to 8.611 miles. And for B, when you cross multiply and divide, you end up with 6.795 miles. But the key was we found that 80, and then we used that 10 to get the ratio. Everything revolved around getting one of these ratios, and then it allowed us to solve for A and B. So law of sines can only be used if we are given an angle and the side opposite it. So up here we were given, it was a little hidden, but we were given the angle and the side opposite it. But if we're not given that, if we're given side, 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 or side, angle, side, we use the law of cosines. So we're going to derive that now. Similar fashion, we're going to drop this h right here, and we're going to call this distance from here to here x right there, and we're going to call this distance from here to here c minus x, lowercase c. Because this whole side, if this is angle c, this whole side is called lowercase c. So I'm going to try to be very particular here. This is lowercase c minus x. It's a lot of c's and x, and these are all angles, so they are capitalized. What this tells us, and if we label these again here, that's going to be lowercase a, and this will be lowercase b. What this tells us is that b, we know that we can use the Babylonian Theorem. We have a triangle right here, right triangle. So that tells us that c minus x squared plus h squared is equal to b squared. And then we also have a triangle right here, which is going to be x squared plus h squared is equal to a squared. So x squared plus h squared is equal to a squared. So we just used the Babylonian Theorem twice there, and we got two different things. What this tells us, though, is we could isolate h on this one, or isolate h squared. If you isolate h squared here, you're going to get h squared is equal to b squared minus c minus x squared. And over here, you end up with h squared is equal to a squared minus x squared. But these are the same, h squared. So that means that these two things are the same. These two things are the same. So what that tells you, therefore, is that b squared minus c minus x squared, that's this one right there, is equal to a squared minus x squared. And this doesn't seem too helpful, but what we're going to then do is multiply it out. And then we end up with b squared minus c squared plus 2x minus x squared equals a squared minus x squared. And then you'll notice that the x squareds cancel out. And let's move this over, so you end up with b squared minus c squared plus 2x equals a squared. So how does this help us? Well, there's a c right there. There's a c right there. Because when you do c minus x times c minus x, you end up with c squared minus 2xc plus x squared. So let's isolate b squared. So you get b squared is going to be equal to a squared plus c squared plus 2cx, and there's this last x here, this last x. So what can we do with this last x? We'd love to make that x in terms of a and c. Well, what we can do is go back and look at our original triangle here. And when I say original, I mean this triangle right there. And it tells us, if we look at that cosine of b is going to be equal to cosine of b, is x over a, adjacent over hypotenuse. So that means that x is equal to a times cosine of capital B. So x is equal to a times that. So we're going to take this right here, and we are going to plug it in right, oh, that went way down too far. It's going to go all the way down to here, into this x. So what that means is that b squared is equal to a squared plus c squared plus 2c times a cosine b. So you can clean that up a little bit. I like putting things in alphabetical order. So you get b squared is equal to a squared plus c squared plus 2ac cosine b. The key thing is here, if this is b, then this has to be a and c and a and c. So there's actually two other ways to write it, just like this. So there's three ways to write it. They're all the same. It depends on which one you want to use. The other thing, as I just caught it here, this is a minus sign, so there's a minus sign in between all of these. There's a minus sign. So what this glues together, remember, lowercase is going to be side lengths, and capital is going to be angle measures. It glues together all these values for non-right triangles. So let's use this information to solve this triangle, which means find all the angles and the missing side length. So let's find a first. The law of cosines tells us, so if this is a, that's lowercase a, so this is lowercase b and this is lowercase c. So what that means is, remember, a squared equals b squared plus c squared minus 2bc cosine a. So that means that a squared is equal to 12 squared plus 5 squared minus 2 times 12 times 5 times cosine of 60 degrees. And you can use you don't have to use a calculator on this, but you can. So what do you end up with? You end up with a squared is equal to 144 plus 25 minus 2 times 12 times 5, and cosine of 60 is 1/2. So the 2 and the 1/2 cancel, so you're left with, when you do this out, a is equal to, a squared will end up equaling 109. So a will equal the square root of 109. So you know that this is the square root of 109. But now that we have an opposite side, we can use the law of sines. So that's going to tell us, and if this is b, we'll call this, we have angle b there, we know that sine of 60 over the square root of 109 will be equal to the sine of b over 12. For example, the sine of b over 12. So when you do this out, how do you go about solving this? You cross multiply. So you end up with sine of b, or just multiply by 12 is fine, 12 sine of 60 over the square root of 109. And when you do that out, what you have to do is you have to do the sine inverse of this thing. And it looks bad, but that just means you use your calculator. So you use your calculator on this, you type it all in. That is equal to angle B right there. So when you do this out, you end up with B is equal to 84.504 degrees. And then once you get that one, once you get two angles, you can get the third, because you know that angle C plus 84.504 plus the other angle, what's the other angle? 60 degrees, plus 60 degrees equals 180. So when you do this out, angle C will equal 35.496 degrees. So we've solved the triangle because we found the missing angles and side lengths. There was one missing side length and two missing angles that we needed to solve for right here.